Hello, everybody. My name's Simon Prickett, and this is a webinar between CrateDB and our partner Data Max. It's a live event. We are here right now and for the next 45 minutes. And what we're going to do is just sit for a moment and let people join. So with a Zoom webinar, there's a couple of things that you can do as participants. You can use the chat and you can use the Q&A. So if you have questions for myself or Cindy, we'll introduce ourselves properly later, then you can use that Q&A tab and we will try and get through as many of those questions as we can. Can't promise we'll hit them all, but we'll try. And if you want to use the chat just for things like let us know who you are, where you're coming from today, and so forth, we'd love to hear from you. So I'm just going to give it a moment and I'll go on mute for now. Okay, so let's get started. Hopefully people have had time to settle in. Like I say, please feel free to use the webinar chat for things such as, hello, I'm whatever your name is and wherever you're from. We'd love to hear from you, what you're interested in CrateDB or Data Max is, or whether you're interested in today's topic, wildfires. And if you have specific questions, we would love to see those in the Q&A tab where we can work with them and hopefully get them answered for you. So let's get going. I am Simon Prickett. I am working in developer relations here at CrateDB, and I'm based in Nottingham in England. I'm interested in IoT, visualizations of data. I'm particularly excited about this project because it uses a map, which is one of my favorite ways of visualizing things. And I'm here today with Cindy Ziu, who I'll let Cindy introduce herself.
Thank you, Simon, and hello, everyone. I'm Cindy. I am a data and AI engineer at Data Max, and I've mostly worked with projects in machine learning and data engineering there. I'm experienced in Python and different cloud architectures such as AWS, Azure, and Google Cloud. Outside of work, I'm interested in a couple of things. I DJ part-time. I'm very outdoorsy, love nature, hiking, and all the sorts. It's really great to see so many people interested in today's webinar, and I can't wait to show you what we've prepared for you today further on the session. I'll pass it back to Simon to continue.
Okay, thanks. And so we've got folks checking in from all over the place. I'll just do a quick run through. We've got people in Austria, India, Germany, Berlin specifically as well, and Albania so far. So if there's anybody else out there and you're in a different location, we'd love to hear from you. So meantime, the way this is going to work is I'm going to very quickly introduce what CrateDB is, and then the majority of this webinar will be Cindy talking about a project that she's been involved in that uses CrateDB and how that works, and that'll include a demo. It's also a project that you'll be able to try out yourself, so we'll be sharing the source code amongst some other resources. So really sort of high-level overview for those of you who've not worked with CrateDB before or seen it before. CrateDB is a hyper-fast open-source database for real-time analytics, AI, and hybrid search. That's quite a lot of stuff. It basically means that CrateDB is a database that is optimized for analytical workloads. It also does AI. We have a vector data type and what we call hybrid search, which is a mix of sort of BM25 keyword search and vector similarity search. How do you get at things in CrateDB? Well, we use SQL for everything. So we are in some ways a NoSQL database, but you have to remember in this case that NoSQL means not only SQL. And we have everything lives in tables. Those can have flexible schemas. And CrateDB is also a distributed database, which is important to know. So here's a quick overview of everything about CrateDB. So this is quite a complicated diagram. We're not going to cover all of it in a short sort of overview presentation like this. But things that you should know is that CrateDB supports all sorts of different data types. So in the center there, we've got JSON, full text, blobs, geospatial, and time series. All of those live in tables. They can all be accessed via SQL. And CrateDB also has a distributed execution engine. So if you're running in a cluster, then the work is shared between nodes. Each of those data types ideally wants a sort of specialized storage solution. So CrateDB uses columnar storage so that we can store each type of data in a way that's most appropriate for it. And we index everything by default, and we use Apache Lucene for that. The product's available on the edge on very small devices, like there's a few Raspberry Pi devices behind me. A Raspberry Pi 4 or 5 would be great for that. You can run it on premises in Kubernetes cluster or however you like. And today we'll be demonstrating the CrateDB public cloud. So just sort of take a cut through this diagram of what we're going to look at today. We're going to start with some external data. So Cindy's got some data about wildfires that I'll let her explain as part of the demo. We're going to get that into CrateDB through a loading process. And we're going to find that that data contains time series stuff. It's got a geospatial aspect to it, so where things happen. And it's also got some sort of full text aspect and the ability to search for things. And once we've got all the data in there, we're going to build an end user application that demonstrates a couple of things. So some real-time analytics queries, and also how to work with visualizing the data in a popular programming language. So in this case, Python. And I'll hand over to Cindy at this point to talk a little bit about Data Max. And I'm running the slides, so let me know when you need the next one.
Thank you very much, Simon. So as we mentioned, today we're going to talk about the topic of wildfires in the US. But first, I wanted to say a few words about the company where I work. So we are Data Max, and we are a data and AI specialized agency. We help our clients utilize and get real value from their data. On the next slide, we can see that we mostly work with data engineering, machine learning, and AI projects, and we're heavily based on cloud solutions. Throughout our projects, we've successfully been able to work with over 25 clients in 9 different countries worldwide. And we are based in Germany, but part of our team is also in Albania as well as in Germany. So to dive right into our topic for today, we're going to talk about natural disasters and especially the wildfire and emergency response. We were driven to choose this topic because of the recent events in the United States of America, especially in the California and Los Angeles area, where no longer than a few months ago, there were a large number of cases of wildfires spread across of the whole area. We got our data in a few different sources from the National Interagency Fire Center, the Department of Forestry and Fire Protection, and we also simulated different data sets with emergency call records. We tried to utilize all the tech that we have at hand to be able to somehow help first responders in making use of the data that's available and make better, faster decisions in resource allocating or the first response when such natural unfortunate events happen. We chose CrateDB for this demo because, as Simon mentioned, it has this multimodality feature. So we could have different types of data, such as relational, non-relational, textual, geolocation data, as well as time series, all inside of one database, which is Crate. Then on the next slide, I'm going to show you a bit of the architecture for this application that we've built. We tried to keep it very simple, just to showcase what can be done with CrateDB in this particular scenario. So as Simon mentioned, this app is built in Python mostly, and the whole ETL is written in Python. So we extract the data from our mentioned sources. We do all the necessary transformations to make it appropriate for our tables. And then we load this data into the CrateDB cloud. Previously, we need to create a cluster for the CrateDB, and then we can create the tables and load the data. Finally, we have created a Streamlit application to visualize all of our different analytical queries that we have prepared. Streamlit is a front-end sort of Python framework. It's mainly used for data visualizations, data science, and that kind of scenarios. Next, I'm going to show you a bit of the analytics that we have prepared for today. Firstly, which I find very interesting, is this emergency calls near fire locations analytics. So we have somehow merged both of the data sets that we have, the wildfire locations data, as well as the simulated calls data. And utilizing CrateDB's distance function, we find all of the calls that fall within a specified radius of distance from these fires. And by some first responders having access to such data in a real-life use case, you could prioritize where the resources would be most necessary to be spread, like where are the fires actually impacting people's lives the most, and where is it more dangerous, and all that. Another query we have, or analytic we have done, is calculating wildfires which fall into a specific area. For example, we have taken the Los Angeles area because it was most appropriate, and we have represented this location as a polygon shape. And using the within clause in CrateDB, we find all of the fire locations that are within this polygon shape. Next, we have done emergency calls related to a specific topic. And here we use the full text search and the match clause in Crate. For example, throughout all of our data with emergency calls, we can filter through whatever topic we're interested in, such as fire, obviously, and whatever other topic which could be mentioned in the emergency calls, which we'll take a look at later. Then we have a few general queries, like most common emergency call topics, average response times, as well as the distribution of fires across different states and cities. So without further ado, let's take a look at a little bit of the code, just to make sure we know how the connection to CrateDB is made, and a look at a few queries, as I mentioned, and then I'll do a live demonstration of the actual app in Streamlit. I will start sharing my screen now, and I hope you can see the screen. Okay, thank you, Simon. So here we have the whole repository, which you will be able to also access later on as a GitHub repository. Here we have done the connection to our CrateDB cluster, which needs to be previously created. And in the GitHub repo, you also have all of the instructions needed to actually create cluster, get all the code, and run the demo step by step. So first, Crate provides this Python client, which we can use to connect to our cluster with these credentials. After we create the client, we can use this client to actually ingest our data into the database or run different queries that we have prepared and get some data in response. Then here we have some of the queries that I have prepared. For example, in the emergency calls subject, here we have the get calls near fires. And what this specifically does is the first query, the first topic that I talked a little bit about earlier, that we join our tables with the emergency fires, emergency calls, and the wildfire locations, and find all of the calls that are within 10 kilometers of a distance from a wildfire. And we will see later on how we can visualize this query into getting some actual insight, which could be useful in a real life scenario. Another query which is related to only the fire incidents is a time series one, which shows us daily fire distributions during the days of a specific month. And here we can notice trends or different statistics that we get from the data. So now let's take a look at the actual Streamlit application. This is what we get in the beginning when we open it, and it's divided into 3 sections. We have firstly the map, where we have represented here all of the data of the wildfire locations. As we can see, unfortunately, in the California area, it's heavily red, which means that there have been a lot of fire incidents happening. This is for January 2025. And here we can select the California area to actually take a look at only the California section. On the second part, we have the emergency calls dashboards and maps. And here we have our data, our generated or simulated data for the emergency calls, where we have gotten location as well as a transcription record. This transcription record would simulate how a call would go between a reporter, a simple human, and the listener, or I don't know, a police officer, the first responder in the area. And we have used this transcription record to actually search throughout using files, text search, full text search, to search through our records and find only the records where fire was mentioned or the incident was related to fire. Crate also provides this score of confidence for the search. And below we can see all of the records that were related to fire. We can also maybe use traffic and see how the traffic incidents are spread out in Los Angeles. Finally, we have the dashboard section, where we have showcased a few of our queries, not all of them, because it would take a lot of screen. But here we have 4. Firstly, the daily fires dashboard. Here we can see the distribution of the number of fire incidents over time, day to day, during the month of January. And we can notice trends and how in January 8th, for example, we had the biggest number of fires with 133, and then it drops down eventually. We have the second dashboard, which is the emergency call distribution. So in this pie chart, we can see how the topics of emergency calls are distributed in 100 out of 100%. And as you can see, the fire-related incidents are the largest. Thirdly, here we can see our emergency calls near wildfires. So what emergency calls were recorded within a location or a distance of 10 kilometers away from the wildfires. And if we zoom in a bit here, because there are a lot of incidents taken into account, here we have the name of the actual fire incident itself. And here we have the call count, or how many emergency calls were registered in the area where this incident is happening. And this could be very useful in a real life scenario if someone would have access to such insights, to be able to actually quickly distribute the resources or firefighters or whatever local institutions that take care of such events, and be able to minimize the damage as much as we can. So if we see that a large number of calls is being made from this specific fire incident location, then it must mean that the situation is very serious and it must be really looked after. Finally, we can see the polygon utilization, where we search for all the fire incidents that have happened within a specific area, expressed as a polygon. So this is the polygon shape for Los Angeles. And we have searched within this polygon all of the fires that have taken place in it, which is 321 in total. And this is only part of all of the analytical queries that we have prepared. But as I mentioned, the GitHub repository will be up and accessible for all of you to maybe try and experiment and try for yourself how to actually use this data. This is a very simple implementation, but I think it has a lot of potential to be expanded and actually used in real life to minimize the damage or to gain some better insight into what data is available and how to best prepare in such scenarios. So that wraps up today's demo on my part. I would pass it back to Simon to show you the GitHub repository link.
Okay,
And
let's swap back to here.
yeah.
There we go. So yeah, as Cindy said, Data Max has graciously made this project available for everybody to try out. So I did share the GitHub link in the chat. So if you want a copy and paste version of it, but also let's put it up in a nice large font on the screen so you can find it. This is really nicely documented. So I've tried it out myself. You can basically just follow the things in the README, and you can either use CrateDB in the cloud, which is you can just use what we call a CR free, so a free trial version for this, or you can use Docker, and you can run everything locally. So let me just also check the Q&A here. So while I was listening to the demo there, I noticed we also have people from Luxembourg, Portugal, Italy, Milan, India. We also have somebody from California as well. So be interested to know where you are in California. I've also lived in California for a little while, so I've had experience of these fires in San Diego. So here's where you can get the demo from. From a CrateDB perspective, you can also learn a bit more about CrateDB and some of these concepts in our academy. Our academy is free for everybody to try. It's online, and the courses are all video-based with a project that you can sort of load data and follow along yourself. It actually uses not dissimilar data to this project. So it uses open data from the city of Chicago relating to things like 311 calls. So where is where are all the reports of things like aircraft noise or potholes in the road and so forth? And we look at geospatial data with that and some search and so forth. And we also look at time series data and all the fundamentals in that course. So that's a really good base thing. So let me just stop sharing, and hopefully you can kind of see both of us. We can both talk now. So Sean in the chat says he's midway between Los Angeles and San Diego. So I'm guessing like Orange County somewhere. I used to live in downtown San Diego and get up there for quite a lot. And yeah, we don't have anything in the Q&A at this point. So if you've got any questions that you wanted to ask Cindy about the project specifically or me about CrateDB, then please feel free to go in there and ask them. But I guess in the meantime, I was just going to ask you, Cindy, what was your overall developer experience of building this project out and working with CrateDB? Because it's something that I'm personally quite interested in enabling for people. So it's always fun to just chat with people who've built a project.
Yeah, it was extremely simple. Honestly, once you set it up in the beginning, you can simply use SQL to just communicate with it. And I think that's very important to keep it as low level as possible to be able to do still great things. So the Python client is very helpful and the SQL is a big plus. So overall, I think it's a great user experience. Yeah.
Yeah, I think that's something we have to explain to people sometimes is like you've obviously used some of the full text search, but you don't have to go learn a particular full text search language to do that. It's embedded in the SQL statements. And similarly with the geospatial stuff, I noticed you've got a polygon on the map for Los Angeles, and that was in WKT or well-known text format. You can use that or GeoJSON with CrateDB. So generally, I find people like building applications that have maps front ends because there's very little impedance between what's in the database and what comes out of the database and what you want to give to a maps library in the front end to actually build something.
Yeah, exactly.
So yeah, that was all interesting. So somebody Sean asked in the chat, where was the data coming from originally?
Yeah, I can show you the website, or it was in the presentation. Basically, the United States have official governmental data sources for such incidents. If I'm not mistaken, it was the Wildfire Incident Agency. Sorry, Simon, if you can share the document again, the presentation.
Oh, yeah, sorry. Let me come back to...
And then on the first slide of our presentation here, no. After that, here, you have data sources. You can press on the first one. So National Interagency Fire Center of America, as well as the Department of Forestry and Fire Protection in California specifically, for the first data set with the wildfires information. And then the second data set that I mentioned with the emergency calls, that is a bit more critical information, I would say. So it's not that easy to get hands on people's telephone calls, but we simulated the data set, we created it ourselves to simply just show how we can do this relation between the two of them.
Yeah, sorry, I wasn't sharing the right...
No, it's okay.
I thought I was sharing the desktop. I was sharing an application. So here's the National Interagency Fire Center data. I could put these URLs in the chat as well. That would probably be a good idea, wouldn't it? So yeah. Let's do that. And here's the California Department of Forestry and Fire Protection. So Cal Fire. So yeah, those are in the chat for everybody now if you want to see those. And if I remember right, the data's also been contained inside the repository, so you don't need any keys or API access.
Yeah. I have downloaded all of the data in CSV and CSV format files, and then we use that to then ingest it into our CrateDB cluster. Everything is separated in folders also in directories in our repo, so you have all of the work processes separated, starting from creating the infrastructure, meaning the tables in CrateDB, and then the ingestion of data, and then finally the analytics and front end.
Okay, and then we have another question here. We are currently ramping up an IoT-based solution leveraging CrateDB. quality of the documentation is amazing and the Academy courses are impressive. Thank you. You'll see me on the Academy courses, but that is the work of a much wider team of other folks that also work at CrateDB. So I'll make sure to field that back to them. Do we have a community Slack or Discord? And then Michael, who's one of my colleagues, has answered, yes, we do. We have community.cratedb.com, which is a discourse. It's forums. So you'll find in here a mix of like articles that staff have published, tutorials and so forth. And it works like a sort of old school message board. You can join here and post your question and so on. So, for example, you can post a question. We love it when you can put a reproducible query or a data set or something in there, because then it's easier for us to help you. So, so yeah, that's everything. So I think what I'm going to do is stop sharing there. So you're back to both of us. And yeah, so I think we've dealt with all of the questions in the chat at this point. So thanks, Cindy, for coming along today and doing a presentation. And thanks also for building the demo. So I hope people will take it and try and play with it themselves, learn something about CrateDB and also about Data Max and what you guys do over there. So do you have any closing thoughts before we leave things for today?
Yeah, I'm as well very glad we could work on this project together, and I'm excited to see how we can maybe further work on it and actually help people, and who knows, maybe save lives. I don't know.
Yeah, so as somebody who's lived through a few of these wildfires in the distance, they affect a massive area because where I was in San Diego, you weren't in danger of your house burning down, but the air quality was terrible and you had to stay inside and so forth. I think it's also a great example of like real-time analytics. There's no point knowing stuff about fire data months afterwards unless you're doing some long-term planning thing. You want to know about something as it's going on. So good fit for CrateDB. Okay, well, thanks for coming along today, everybody. We'll see you on the next one of these, and you can always get the resources to try this out yourself. The link's in the chat. We'll make sure that wherever this appears as a video in future, the link is also in there, and we'll get the video to this webinar referenced in the README in the GitHub as well. So everything you need should all be together in one package. Right. Thanks very much, everybody. We'll see you on the next one. Bye for now.
Thank you, everyone. See you.